This is example 4 in section 4.9. We are going to find the dy dx for this relation. And you notice that we have x and y variables, so we'll differentiate both sides. So we will differentiate each term to find dy dx. When you differentiate x cubed, you will get 3x squared, derivative of x with respect to x, so we know this will cancel. We're going to use the product rule for the next term. So you take the first function and you differentiate the second. When you differentiate y, you get 1 dy dx. Plus the product rule, you take the second and you differentiate the first. So the derivative of x squared is 2x times dx dx. Now, in the right-hand side, we have another product. So we take the first term, y squared, and we differentiate x, which is just 1 dx dx, plus x times the derivative of y squared is 2y dy dx, plus the derivative of y cubed is 3y squared using the power rule times dy dx. So we know our dx's are going to cancel, dx with respect to dx. So we have left 3x squared. We'll distribute our negative through. So we have minus x squared dy dx. Subtract 2xy equals, we have a y squared. We have a 2xy dy dx. And we have a 3y squared dy dx. So you notice we have 3 dy dx's, and that's because we had 3 variables of y in the original. So again, we want to combine our like terms of dy dx. So I'm going to leave the 3x squared, the 2xy, and I'm going to move this y squared over. So then I'm going to equals positive x squared dy dx, so I move that to the right side. I already have a 2xy dy dx on the right side, and I already have the 3y squared. So you can see now that I can factor out these dy dx's. So if you take out a dy dx, you're left with x squared, 2xy, plus 3y squared equals everything on the left. And then to get dy dx by itself, we're going to divide by that term trinomial. And then we divide the other side as well. So our answer is going to be dy dx equals 3x squared minus 2xy minus y squared all over x squared plus 2xy plus 3y squared. Again, this derivative is dependent on the x and the y coordinate because we have both variables.